Hello everyone. Today we will going to do the another problem of linked list, that is swap nodes in pair. This is problem number 24 in Leet code and it is of medium level. So this problem asked in generally so many interviews like of Amazon, Walmart and of Google also. So it's an important problem. So let's begin with the problem. Given a linked list, swap every two adjacent nodes and return its head. You must solve the problem without modifying the values in the list, that is only nodes themselves may be changed. Means we can't do any type of swapping in linked list, and we have to swap in pairs like 1, 2, 3, 4. So the swapping in pairs will become 2, 1, 2 goes to first and 1 goes to second place, and again 3, 4 becomes 4, 3. So how we will going to do this? Let us first discuss the approach. So the approach will be like this. Suppose we were given with this linked list, and at the end this 6, the last element, is pointing to null. So what we will do in beginning, before starting any loop or any kind of logic, we first do some kinds of trick. Like first what we will do, we will point this current to this 3. Means initially our head is at this position. So what we will do, we will point this current as head of next dot next. Means current will point to this 3, and after that we will take previous as this location of head. Now we will shift this head to this next element. Means head equals to head dot next. So why we are doing this? Because in final printing the 2 will come at first position, that's why. And similarly head dot next becomes 1, or we can say head dot next will point to this previous, so it the connects. So we will see this arrow which is now pointing to this 3. Now this point will break, so we can see this, and now this 2 will point to this 1. After that we will start implement our looping. So the loop will be some, let don't understand the loop will be implement in coding part, let us understand the logic. So now what we will do next, so we simply do that this previous, so we know that now head is pointing to this 2 and 2 is pointing to 1. So after this, so if we go for printing, then it will be like this. If we print head, then it will print 2. Let us take off different color, answer 2, and after 2 it is pointing to 1. So after 2, 1 will print. So now we will shift this one. So the connection of this one, which is currently pointing to this 2, we will shift it to 4. Something like this. So and we will shift this previous to this current. Now previous and current are at same position. So now what we want, we will just like before we do the process with 1 and 2, we will repeat this process again with 3 and 4. And for this we need one more variable which is pointing to this 5. So we take another variable, that is nxt, and nxt will point to the next of this current. So current is at 3, so next of this current is 4, and the next of this 4 is 5. So NXT will point to this 5. Now what we will do, we will simply put the next of this current is equals to current. Means after this 3, what we will do, we will have to go up to this 5. Correct. Means this 3 will point to this. Sorry, it will not something like this. Forward there. We will simply do that. The next of this current will equals to current. Means the next of this current is 4, and the next of this also is 5. So just now this 4 is pointing to 5. So similarly we did with this 2, like this 2 will start pointing to this one. Similarly now this 4 will start pointing to this 3. And again we shift this current to this NXT. Means in printing it will go like first 2, then 1, then after that it will simply the 1 points to this 4. So now 4 will come, and after this 4, this 4 now is pointing to this 3. So it will print 3. As we have stored this NXT store the position of this 5. So now we shift this current to this 5. So now current we will go from here to here. And similarly the same process will repeat again and again, and like this way, in place of 3, now 3 will start pointing to this 6, and 6 will point to 5. And finally when the loop gets break, this 5 will point to none. And as we know that we shift our head to this 2, so it is still pointing to this 2 for printing purpose. When we return this head, finally it will start from here, and as start printing from here, it will print the output something like this, which is our desired output. So let's come to coding part. So as per our base condition, we will check that if head and or the head dot next is not none, otherwise we will simply return the head. If head, sorry, if head equals to none, or head dot next equals to none, then we simply return this head. Now what we will do? So we have to do the initial process with these 2 elements. So initially current equals to head dot next dot next, and this previous will point to this first value, that is 1. Previous equals to head. And now we know that we have to start printing from here, so we shift this head from here to here. Initially head is pointing to this one, now head is pointing to this two. So head equals to, sorry, head equals to head dot next, and again head dot next will be previous. Means this 2 is pointing to this 3. Now it will, what will do, it will start pointing to this 1 because previous is 1 and head is at 2. So head dot next will become previous. So head dot next equals to previous. So what we do, we have done our initial working. So now head is at 2 and this 2 is pointing to 1. Okay, so we will start our loop while current does not equals to none, and also, sorry for this. Okay, sorry for this disturbance. And current dot next also not equals to none because we have to do swapping between swapping, or we are working with two elements, that we will come in a loop. So what we will do now, we will shift the previous of next equals to current dot next. As we see in our diagram, initially current is pointing to this 3 and previous is at this position. So now the next of this previous is start pointing to this next of current. So 1 will point to 4. So we will do same, means previous dot next equals to current dot next. Okay, so current dot next is 4. Now what we will do, we will shift the previous to current. Previous equals to current, and now we take another variable, that is nxt, which is point to the next of current for the further process. Dot next. Okay, current dot next. Now we will do, so now we will shift the next of current to current, means as we did, the next will become 5 and the next of current means current is over here, next is 4 and next is 5. So 4 is pointing to 5. Now 4 will start pointing to this current, means 4 is pointing to start pointing to 3. So current dot next, sorry, next dot next equals to current. Okay, and now we will shift this current to this nxt. Why? Because for the further process, now will current will shift from here to here 5, so that we will repeat the process again in next iteration. Current equals to nxt, and then when the loops gets finished, so we will, what we will do, previous previous dot next equals to correct, and simply we will return the head because head is still pointing to this 2, from where we will start printing. So return head. That's the code. So it is giving some error. Previous is not defined. PREVI. Oh, sorry, I did spelling mistake. The spelling of previous is PREVIO. So I missed that U. Not works fine. And after submitting, okay, so it works completely fine. It is running in 48 microseconds. So now finally will see the code in C++ also. This is our Python solution which is working completely fine. Now our C++ solution is, let's see. So the logic and approach is completely same, only the variables is different and everything is same. So in the beginning we checked that if head is equals to null, or since it is Python in place, sorry, it is C++ in place of none, we are taking null, or head of next equals to null. Then we return head. Then for creating these variables we use list node current equals to head of next dot next. So these are the same initial line. So that we did in same. And then our looping part, it has implemented the same logic. Everything is same. Only the syntax has changed as per the language. So I'll run that also and submit. So we can see that it runs in 0 microseconds, faster than 100%. No wonder why, because we can clearly see that the C++ is quite faster than Python. That's why we can see this change. So this is, we can also say that this is the fastest way of doing this code. So thank you for viewing. We will come again with a new code of DSA. Please be with us.